What we're going to look at today, it's called the dot product. It's an operation we do with vectors. Now the dot product is useful because it tells us the likeness of the direction of two vectors. Now before we go into how we determine the likeness from it, we'll look at the operation. So if we have vectors A and vector B, we can calculate the dot product of vector A and B, so A dot B is the same as saying this member times that member times that member times that member, and you sum them all together. So we're going to go A1, B1 plus A2, B2 plus A3, B3. Actually computing this, it's 3 by 3 plus minus 4 minus 5 plus 1 minus 2. Usually you would use a calculator for this, but we do have to know the manual method. 9 plus 20, take 2. So this will just be 27. So the likeness of these vectors A and B is a score of 27. Now, we'll elaborate on that in a sec. Before that, I draw your attention to the board. On the board, you're going to see the vectors, or two vectors, vector A and vector B. I've scaled these down so they're the unit vector. So even though I draw A and B all the way out here, I've made it so they're the unit vector. So they're a distance of 1 in length. Now, looking at this, what I'm going to do is, I'm going to have the vectors point in the same direction, or a similar direction. So it's vector A and B. When they're pointing in a similar direction, if we look at the dot product here, what score do we get? Can you see that?
0.5.
Yeah, 0.55. So it's a little bit hard to see and I can't zoom it in. Now, as I bring the vectors together, oops, what happens to that score? 0.74.
It goes up.
Yeah, it goes all the way up until we get to a score of 1. And then when they start moving apart again, it starts going down.
What if alpha equals 0 degrees?
So when 0 degrees, it's 1. Good question though. So when they're pointing in the exact same direction, the dot product of two unit vectors is 1. Now, what about if we start moving them pointing away from each other? What happens when they're pointing away? It's negative. And when it's, let's put forward a conjecture, negative 1. When they're pointing in the complete opposite direction, it's negative 1. So we can put two things together. When they're pointing in a similar direction, the dot product is positive. When they are pointing in the different directions, it's negative. The closer they are to one another, or the further they are from one another, will make it go really positive or really negative. Now, if it's equal to 1 when they're pointing in the same direction, this is unit vectors by the way, so it's got a length of 1. When they're pointing in the same direction, it's 1. When they're pointing in opposite directions, it's negative 1. Any ideas, what will it be when they're perpendicular?
0.
0, you remember this from last year?
No.
So the dot product tells us the likeness of direction of two vectors. So if they are pointing in a similar direction,
How do you express dot product? Do you do dot and then in brackets P?
vector 1 dot vector 2. So it's a bolded dot.
say you're like writing it, you just write dot and then p in brackets, like dot p equals.
Could you show me?
So say if I wanted to say the dot product of this is 0, would I just write like dot p? Is that how you express?
No, just write it black on the board.
Okay.
Vector 1 dot vector 2 equals 0. So pointing similar, you're going to get A dot B will be greater than 0 when they're pointing mostly dissimilar. I would say mostly opposite. Then you're going to get A dot B is less than 0. And then the final one, perpendicular. You get the condition that A dot B is equal to 0. Does that make sense?
Yeah.
Now what about if we wanted to check if two vectors are perpendicular?
Set 0 by the way.
Checking for perpendicular, what you're going to do is you could have vector A, let's go vector C and D. Vector C equals and vector D equals. If they're perpendicular, then what we end up getting is a condition where C dot D will equal 0, and if that is true, then that would inform that C is perpendicular to D. Now, let's pick two vectors. We're going to go that and that. Could you read these numbers out for me, please, Lenny?
0, 2, 0,
And
1.5, 0, 0.
great example here. Alright, if we wanted to check whether these two vectors were perpendicular, then what we'll do is we'd go for this relationship here. Vector C is perpendicular to D if vector C dot vector D equals 0. How do we check this?
Dot product.
Dot product, LHS equals C dot D. Normally I would put in the values here, but we're limited to space, so we're going to go for using calc. So we reach for our calculators, boys. Run matrix. Clear out the old memory. Do we want to key the matrices in, or do we want to put them in memory? Let's key them in there. Alright. So we're going to go for options. Map back to begin with. Go across. And we see dot. Click that bar. Next we go extra twice, and we're going to key in our vectors. So we're going to go map back, and you can either do a 3 by 1 or a 1 by 3, it doesn't matter. I've written them on the board as row vectors because it saves space. You can also do a column vector.
So what's more conventional?
In South Australia, I believe we typically only use the column vectors, but
Yeah.
it is fair game if they wanted to put it in an exam. So we can put them in like this. Was 0 to 0, 1.5, 0, 0, and indeed. Any surprises there?
Yeah, but it was like 4:30 for security.
I was playing at 3. I don't know, I was playing. It was on, I was on Thursday.
Come on.
But
Yeah, I'll do it.
Relatable. I was up at 2 doing.
I fell asleep.
I did a couple of
I
sentences
got
in the investigation.
I got
So
soccer and just fell asleep.
did a couple of sentences in the investigation myself.
I got home from soccer, fell asleep, woke up at 11:30, and then Dad was like, hey, it's the video. And I was like, yeah. He was like, alright, let's watch it. And that one was at 1:20.
Seems like this one's heedlessly.
Alright, so there we go, guys. That's how you would check if two vectors are perpendicular.
Lovely.
If you want the force vectors to be perpendicular, it's basically the same except you just sub in some variables to figure out what the variables would be. Any questions?
You go on with the question?
Mm-hmm.
What does it mean, check?
Check.
Check.
It says question 4, question 5, question 6, then check in brackets.
Just check it's true.
With you?